Hey, this is OXDF, and today we're looking at day 4 of the 2023 Revival of Code / 2016 Advent of Code. Puzzle is named Security Through Obscurity. I get a bunch of lines of text that have a checksum and an encrypted name and a sector number. I need to parse that out into various pieces. I'm gonna actually go a little bit overkill and create a class, and I can use tests to drive the development of that class. And then from the class, I can pass the string and then get back at first whether it's a valid name or not based on a checksum, and then later decrypt the name from there. So um, again, I think I went a little overkill, but it was fun and a good experiment. So hopefully you'll learn something. Let's go ahead and check it out. All right, let's take a look at security through obscurity. Basically, I'm going to get a bunch of lines, and each line is going to look like these things here. And the line is made up of an encrypted name, which will have letters, lowercase letters and dashes, so basically that. Then there's going to be a dash, then a sector number, then square brackets, then a checksum. And that's basically it. The trick is in calculating the checksum. The checksum is going to be the most common 5 letters, and if there's any ties, we sort alphabetically. So in this example, the most common letter is A comes first. The second most common letter is B comes first. Then there's X, Y, and Z all show up once, so we show those alphabetically. Here, you've got, like 8 letters that are all 1. So we pick 5 of those, so it's A, B, C, D, E. They're going to be the first that come alphabetically, and that's a checksum. Same thing here. O shows up 3 times, I believe. 1, 2, 3. Then A shows up twice, R also shows up twice, but comes after it in the alphabet, etc. And then here's one that is not a real room because decoy, D is not even in here. They want us to sum up the sectors of the valid room. All right, let's jump over here. We can do, genday, day 4. This is my script. It's a shell script that I source, and it will create a directory with put some stub files in there and download the input and put me in that directory. I've got a video that walks through the details of that. You can check that out. I'll link it here. You can look at the input.txt. There's just a bunch of lines. They all look very varied in length, but for the most part, similar. Looks like we have about 980 of them. So nothing too exciting there. There is a trailing new line on the file. I always want to keep that in mind. Let's start by doing some tests. And this is going to be the first time that I'm going to do something a little bit more with parsing. It's probably overkill, but I'm kind of thinking it'd be fun to do, so we're going to do it. I'm not going to do any reading out of a file. My input might be getting big enough that it might be worth storing it in a file, but for now I'm going to stay with what I got. And I'm going to, before I even get to testing part 1 like this, I'm going to make a test for, I'm going to make a class. That class is going to hold a room, and then that way I can pass a line to my class, and then my class will be able to store the different parts, the encrypted name, the sector, and I'll have an isValid function that'll check the checksum. So that might be overkill, but it'd be fine to do this in a loop. But I think it's gonna be kind of fun to do. So we're gonna test that. So we're gonna do def test. We're gonna call the class room, and I think I'm still gonna go ahead and parameterize this so that I can do all 4 of my input, my test things here. I'm gonna move this over to my other monitor so I can copy off of it. And now I can quickly grab. Let's see, grab my. So if my, let's see, what is it going to be? It's going to be P input, and then from there, we're going to need a name, sector, checksum, and valid. So for each one, we're going to have these 1, 2, 3, 4, 5 things. So for example, for this one, if our input is this first one, our name is going to be that. Our sector is 1, 2, 3. Our checksum is A, B, X, Y, Z. That'll be in quotes. And then this will be true. So similarly, we can grab the next one here. We're going to just do this for all 4. I might speed through this so that you don't have to watch me copy and paste too much, but it's only going to take, we can whip through this pretty quickly. Back, I've got those 4 test case in. So now we need to pass those as parameters here. So we can do name, sector, checksum, and valid. And so what PyTest is going to do is it's going to say for each of these things, call this test, and then line these things up as the variables passed into the test so that I can run the same test multiple times. So what is our test going to be? Well, we're going to say we're going to make a room is going to be equal to, we'll need to see aoc.room, which we haven't defined yet. And that room is going to take in the p input like that. And then we can start to do some assertions. So we can say assert room dot checksum is equal to checks. I'm not sure why I'm starting with checksum. We can do assert room dot name equal to name. Assert room dot sector is equal, need two equals there to sector. Fix that in both all these places. So basically we're going to say if we create a room object, these things should, this is how it should parse correctly. And then probably the most important one, room dot is valid. Again, we haven't created this yet, but we will, is equal to valid. So now, if I come down and run this, I test, it's going to fail. And it's going to fail miserably because we're hitting errors here where, let's see, number of names is wrong. 1, 2, 3, 4, 5. 1, 2, 3. Oh, I have to put the values in here. True and false. Okay, boom, that's better. Let's do PyTest. There we go. Now we have four failures. If we come up to the very top, we'll see 4 failures. The rest are skipped. That's the ones we haven't defined yet. And each time it's failing because, you know, day 4 has no truth. This thing doesn't even exist. So we need to go make it. That's how you do test-driven development. So we'll come up here and we will do, let's see, class room. We can do def init, and we're going to take self and align. And now we need to go ahead and define like break our stuff up, right? So we can do self.name is equal to let's see. Let's go up a second. We're going to do line.split. In fact, first we're going to strip it because I don't want to get, if there's any new lines or white space on the outsides, I want to get rid of it. Then we can do split, and we're going to do an R split on dash. And what that's going to do is it's going to find, and comma 1. So we're only going to split once. We're going to go to the right side. We're going to find the first dash, and we're going to split once. And what's that going to give me? That's going to give me self.name, and that's going to give me, I'm just going to call it data for now because it's giving me some other stuff. It might be helpful if I grab, let's see, one of these things and create room from line. So now have some doc strings or something here. I don't, that looks pretty awful, doesn't it? Anyway, we'll go with that for now. I'm gonna black just see that. Okay, it's happy with it. We'll deal with it. So now we've split here, and we got this stuff, and then this stuff right here is in data. So data, we're gonna do data.split. Sorry, R split. It shouldn't matter, but we'll do it just in case on the open square bracket. And we actually want to leave the closed square bracket off too. So we could actually do data.R strip on closed square bracket, and that will get rid of any closed square brackets on the end. Then we can do an R split on open square bracket, and the results are going to be sector, comma, self dot checksum. That let's make we just make sure we only split once, and then we can do self dot sector equals int on sector. I think we're actually pretty good there. Let's run this test and see what we get. We're still probably gonna fail all 4, because room object has no attribute is valid. Okay, let's come down here and we can say def is valid self. And we could type in here. Let's type int string, and we are going to return bool from typing import. No, I guess we don't do that here. We just do bool. And if we just return true for now, let's just do that for a second. Now, what I expect then is that 3 of these are going to pass and 1's going to fail. And that's exactly what happened. You see, we got 3 passes and a fail. That's pretty cool, actually. We have the one that was supposed to fail failing, and the other one's succeeding. let's actually do this for real then. So how are we going to calculate the checksum? Well, the checksum we're going to do, let's go ahead and do from collections import counter. And this is just a handy way to count things. So now we can do counter equals counter self dot name. And actually, let's do dot replace dash with empty, so we get rid of the dashes because we don't want to count the dashes. Now we can do top letters. Let's just call it top 5 equals counter dot most common 5. And now, so we're going to get the 5 most common things. Now we're going to want to sort them. So we can say sorted top equals sorted top 5 key equals at lambda x. And so what this says is basically when I say key equals I'm defining a function here. So each item in the list is going to get passed in as x. And we just want to return, we're actually just going to do a tuple where we do x, first x sub 1. I should talk about most common is going to return tuples where the first item is the key. So in this case, the letter. And the second is the number of things. The first thing I'm going to sort by is the number of things. So that's x comma 1. And then I'll sort by x comma 0. And that should actually do it right there. And then I want to return. So I guess I can say, let's just while we're typing this out, checksum equals join. So we're going to join together, and we'll do x for x in sorted top. So now we have that, and we just want to get x sub 0, the letter itself. And then we can return checksum equals self dot checksum. Boom. Let's see how we did. We failed 2. So we actually have, it's interesting. We had 2 that should be true. So we did return false what we were supposed to, but we had 2 that were supposed to be true that did not. Let's see if we can print checksum self dot checksum. Whoa, it's not subclass hook. Checksum. See what happens when we put that in here. I scroll up some, get these. Okay, so here we get, okay, so the first one we're actually going back. So if we actually want to sort in reverse, we want the highest to lowest. So we're gonna make this a negative. That's gonna fix that, I think. We still are having a failure here on this one. And we we want to get OAREL, and we're getting OARNT. I better put self dot name so I can see what the heck we're looking at here. Not a real room. So O is most common. We got that. A is good. R is good. The next thing we have is N and T, and we should be getting E and L. N shows up once and T should. You know what? Okay. When we do most common 5 here, we're getting that pre-sort. So let's actually get rid of this. Now we're going to get all of them. So we'll just call it counts. And this, and we can make this sorted counts, and we'll make this counts. And now we should have our check. But now we only want sorted counts the first 5. So now if we PyTest it, sweet, our tests are passing. So we now know from our tests that we can take a line and parse it into a room object, and get the valid checksum off of it. So now we're going to say rooms equals, let's actually do lines equals puzzle input split lines like that. And now we can say rooms equals R for R in lines. And we can just do room of R. Now we can return rooms. So that room, we should get a list of all the rooms as room objects to parse the data, and that makes part 1 very easy. We'll just pass in this data will be a series of rooms, so we can just say sum. We can say R for R in data if R dot is valid. We don't want to just get the whole room. We actually want to get the R dot sector. We don't get any autofill there, but that's okay. And now we just return that. Oh man, brutal. Okay, hold on. We pretend we didn't do that yet. Let's go back here and make our test. So we're going to implement our test here on section on number 1. We are going to, let's see, we need to get, this is actually going to be all of these. So we're going to grab this like here, copy, new line there, copy, new line, paste, new line, and the last one, copy, and we'll paste this in. And then we'll add a new line at the end because there's always a new line at the end. And then our total was 1514. We don't need that. We only need one. When there's only one, I actually, instead of parameterizing it, by the way, I could just set these as statements in here. But because of the way I've set this up with parameters, it just makes sense. It's fine to do it this way too. All right, so now we failed because we have none equals 1514. Now we come back and we pretend we write this really simple line and we see we passed. So we've got an answer. Let's go ahead and come up here in F5 to run this. We get a new terminal here and we get, oh, we probably don't need printing. Let's get rid of our print. Get rid of our debugging here, F5 this, and we get 185, 371. We will pull window, whoa, over here. Make it big. We will paste. And we will solve. Let's go to part 2. All right, so in part 2, we're going to decrypt the encoded names of the valid ones. So it's a shift cipher. So basically, if you shift 3, you'd go from A, B, C, D. If you have shift 1 on Z, it becomes A. 2 on Z becomes B, etc. And the amount we're going to shift by is 340, or is the sector ID. And we need to look for North Pole objects. So I don't totally know what that means yet, but presumably that's going to be North Pole in the name. It does also say that we replace dashes with spaces. And I guess that's about it. Let's see. We'll go ahead and I'm going to grab this right here and flip back to the code. I'm going to create a function. We'll start with the function as part of room here. So we can say def decrypted name self, and it's going to return a string, and we're just going to pass for now because we want to create tests, right? So we'll come up here and we're going to create a new test because we're going to have different inputs here. Def test room decrypt, and we will say, let's say line equals this. Now we don't actually know the checksum of this. I don't actually care about the checksum here, so I'm actually gonna, for the sake of this test, I can just put in anything. Or in fact, we can just leave it blank and let the checksum be blank. So we can do line of that. We can say room equals room line. So now we're gonna have our room. This will be aoc.room. Then we can say assert room.decrypted name is equal to, and we need to get that from thing, very encrypted name. Perfect. So let's go down here. We can run a PyTest again, and we're failing. We're failing because let's see, decrypted name is a function. Make it a function. Now we're getting none is equal to very encrypted name. Perfect, because we're not returning anything. Let's go decrypt. We're gonna need to do a shift, and the shift is going to look, in fact, I'm probably, why don't we actually, we're gonna call an audible here. Def shift. I don't even really need self here, but we're just gonna do it as part of the thing, and we'll make it inc. And we're going to return a string. We need that to be a string as well. And so the shift is going to look like, what do we going to need here? We're going to need from string import ASCII lowercase. We'll do as LC just so we have it nice and easy to use. And now we can come down here and we can go ahead and say So we are going to do a lookup table. Is going to be make string.make trans, and then we're going to pass in what our initial one is and our output. So our initial one is going to be lowercase plus, and we're going to put this on the end, the dash. And then the resulting thing we want is going to be, let's see, we have a string. We also are going to need a number here. Oh, I guess we'll have the number. It's self.sector, right? So now we're going to say shift num equals self. Let's call it shift. We'll call it s. Is that too much? Too short? We'll go with s is equal to, because I'm gonna have to use it a couple times. Self.sector mod 26. Because at the end of the day, if you shift things 26 times, it's effectively shifting at 0. So we don't need to do all those extra shifts. So now we can say lc starting at s plus lc up to s. This is just going to sort of swap that around, and then we'll say plus, and we want to put a space at the end so that when we have a dash, we get a space. And now we can say, I always forget how you do this one. It's lookup. No, it is inc.translate. Yeah, there we go. On lookup. I think that's right. And we can return that. And so that now we can go here and we can say, we should have written a test first. We should have def test shift, and we can do, that should be a good one to parameterize. We're not going to need nearly as much stuff, but let's come here and we'll do in enc plain we need, and then we'll pick a few things here. So we can do we don't actually know the decodes of these, but we can just do like, we have all A's. Oh, we're going to need a number. Num like that in plain. So if we have that, we have the number 0, we're going to get back A. We have A, B, C, Z. We're just making some tests here. Let's say we want to do 5. And we'll just kind of, in our head, we can figure out what these would be. So A becomes B, C, D, E, F, G, H, and then this would be E for Z. And then maybe we can do one more. We'll actually do the example from here. So we can do this. Like that. And we'll do 343, and we will do very encrypted name. Sweet. So now with all of those sorted, we need enc num plain. We're going to test that AOC dot, oh, we need a room to do the shift. Huh. Maybe we're gonna cut all this. We could just take the shift out of here and remove self. We'll do. Oh no, we need the sector though. All right. Tossing all that away. I might cut that. We're gonna stick back here with this. We're gonna get room decrypted name is equal to very encrypted name. We're gonna be happy with that. We're gonna come up here and say decrypted name is equal to self.name self.shift. In fact, why don't we just get rid of this entirely? We do this, and then we do self.name like that. There we go. We have solved it. That was a little bit of a, again, strategically not organized in my head quite right, but we got there, right? I think. Let's test this, and we're passing our test. So now we can get the decrypted name off of a value, and that's what we've been trying to do. So to get part 2, we need to do something. I don't actually know. So I guess what we're going to say is there's not really a good test here for part 2 other than to say we need to do some exploring. So let's go here and we can say R for R in data if R dot is valid. We'll call this valid rooms. Then we can say r dot encrypted name for r in valid rooms if north that we're looking for, North Pole. We should make it lowercase. In r dot decrypted name. In fact, we don't even want decrypted name here. What we want is sector. Candidate print candidate. Candidates. Let's try this. Let's go ahead and we will F5 this and see what we get back. Nothing. Try looking for poll. Oops, don't want PyTest. Let's try. Run to here and see, are we getting nothing back? Debug poll candidates 984. Oh, we do have something. Why do we not print it? We are printing it just before we print part 1. 984. So let's see. I guess what is our test here? Best guessing that was also there when I had it at north too. Oh well. Yeah, 984 has always been there. Cool. So I will do return candidates.next and rerun this. And we kind of broke from our test driven stuff here, but I'm not going to go back and try to make ourselves have a test. Oh, we don't have a, that's not what I want to do. I want to do next on candidates. That rerun. Not, sweet. 984. Let's go see if that's right. This has been a slog, so we got it. So what I did here at the end is I basically said, get all the valid rooms just like I did in part 1. And this time I'm going to say, if poll is in the decrypted name, then get the sector. And there's only one. So I get the next gives me the first. I make a generator here. So that'll be a generator that is going to give me all these lists. I call next to get it out, and I've got it. So I guess we succeeded there. Went way longer than I expected. Hopefully you got something out of it. Thanks for hanging around with me till the end. I'll talk to you next time. Bye.